What? Someone's saying that I should avoid the word coronal. How can I? Are they saying that will get us filtered by YouTube because we're
It
saying,
could be by the automatic filters because they're
yeah,
being aggressive.
yeah, I know they're being super aggressive. That's funny.
Yeah.
Oh man. Hey everybody, welcome to the Weekly Space Hangout. I'm gonna say hi to Andy Cowley, Ben Kalo, Bobby Pullett, Brexit Denier, David Dunn, David Fairweather, Eric One, Horizon Brave, Ian Farquharon, Kevin Ayers, Larry Beckham, Miss Scooper, Nancy Graziano, Neil Yu, Paranor, Rich Wilson, Scott Bragdon, Susie Murph, Undercover Steve, Visto Tutti, Wayne Johnson, and Zap Van Zap Van. Hey everybody. I hope everybody is is safe, healthy, and is coming to grips with their new, hanging out in your houses for a little while, a certain amount of containment. We sure are. The rule we've got here is the only person who's allowed in our house is a person from Health Canada who wants to test us for the coronavirus because we've been in contact with someone. It's the only person who's allowed in the house. And the only reason we're allowed to leave the house is to go get groceries, see the pharmacist, or go to the hospital because we're having trouble breathing. And we can go for walks out in the sunshine, in the forest, away from human beings. That's our role. Take the dog for a walk. So, and I hope that everybody is doing some similar version of that. And it's crazy because what was it, 3 weeks ago I canceled our trip to Japan for nervousness
out of an abundance of caution.
Out of an abundance of caution, and it's funny to me how torn I was as well. I was totally like, oh, I'm sure it'll be fine. We don't have to worry about it. And like, we would have been back on the 10th. We would have been back like a week ago. And it was already starting to get kind of crazy. So, yeah. Don't touch your face, Fraser. All right. Well, unfortunately, I haven't left the house. So, all right, cool. Well, we're going to get things started here. All right. There's me. Let me get our intro here. All right. Hello and welcome to the Weekly Space Hangout for Wednesday, March 18th, 2020. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about the Gemini Planet Imager Exoplanet Survey, Venus approaching greatest elongation, finding black hole mergers from public data, Mercury, the heat on Mercury helps it make ice. What? Joining me this week on my screen. Oh, everybody's on my screen. Hold on. There we go. We've got Beth Johnson. Beth, welcome back.
Hello.
Wait, there you are. Hello again.
Hi.
Let me guess, you're working from home.
Always, but definitely now.
Specifically now, working from home. Yeah. Yeah.
The main thing is that so is everyone else on my team. So all of a sudden I get all kinds of meeting requests.
Did you see that ESOC is now running space operations mostly from people's homes?
Oh man.
Yeah. I mean, sure NASA will be next, right? Because they got to run operations. Yeah. All right. We've also got Moya McTeer. Moya.
Yeah. Hello. I had a little bit of trouble unmuting myself, but I'm here.
Also in another hot zone here in the U.S.
Yeah, in New York City.
In New York City, yeah.
The hottest of zones.
Yeah, it's pretty crazy there. So don't leave that building.
I'm not planning on it.
All right, and we've got Brian Coberline. Brian.
Hi, everybody. Also working from home with a wife and a kid and a cat.
Yeah. Well, you'd made that transition a couple of months ago, so you're
I did, but my wife and kid didn't. So.
Oh no, okay. Just lock the door at some random point, and then leave them out with the zombie horde. All right, so before we get into this week's episode and interview, I just want to take a second and make a big thank you to, of course, our good friends at the Weekly Space Hangout crew. They are the producers. They are coordinating everything. And I think at this time, if you're looking for people to talk to hang out with, to help bring down your anxiety when you've just been spending hour after hour scrolling Twitter, looking for that next tweet that's maybe going to, be the good news or the apocalypse that you don't want to see, come and hang out with our good friends at the Weekly Space Hangout crew. Talk about space. It's cool. So go to wshcrew.space. And as always, I'd like to give a big thank you to Nancy Graziano and to the rest of our of the team there for helping to organize all the guests. And before we move on to the interview, I just want to give a huge congratulations to Morgan and Katie on their marriage yesterday. This was not the wedding they were planning, but they were able to tie the knot in a mostly empty I don't know, like some kind of judge office or something. So they tied the knot, which is great. So congratulations,
Courthouse?
Morgan.
Is courthouse the word you're looking for?
Yeah, courthouse. That's it. All right, let's move on to the interview. So joining us from the SETI Institute, we've got Dr. Meng Jin. Dr. Jin, welcome to the Weekly Space Hangout.
Hi, everyone. Thank you, Fraser, for having me here. So my name is Meng, and I'm a research scientist at the Cal State Center of SETI Institute. So I'm a heliophysicist. So that means my research is focused on the sun and how it influences us. So more specifically, I'm working on the numerical modeling of solar wind, coronal mass ejections, or you can call it the solar storms, and also the shocks driven by the solar storm, and also the solar energetic particles. And all of these are the major source of space weather that at the Earth. So because of that, part of my job is also to trying to transfer the research model I'm using to a space weather prediction model, so we can have better prediction.
So
and more recently, I'm sorry.
Oh, go ahead. Oh, you're going to say more recently.
Yeah. So more recently, I was involved in the solar stellar connection studies that I'm trying to applying the solar model that we use to understanding our sun to the actual solar system to understand the stellar wind and stellar coronal mass ejections, so that we can understand the star planet interaction better and also the habitability.
So how well right now do we understand the connection between the weather on the sun and its interaction with the Earth? How much of a warning do we have?
I think the prediction has been improved a lot because we have more and more observations over years. So if you look at the observational system of heliophysics, we got many satellites over years to observing the magnetosphere, observing the sun, both for remote sensing and in situ measurement. So we got a lot of data. So I would say the forecasting capability is keep increasing over the last decades. So at the beginning, what we used to for prediction the space weather is based on the solar observations near when the coronal mass ejection just initiated, and we know speed, and then we can estimate using a simple kinematic model and do the prediction. But the problem is that we don't know the background solar wind conditions. So in most of the time, this prediction can be off by like more than 10 hours. And then there's an improved model to do a better modeling effort. Is the cone model that is now is widely used in the community to do the prediction that we can, because we have the observations from different point of view, like the stereo is provide us with two different view within the same coronal mass ejection. So we can do the reconstruction of the 3D structure. So we get a better idea of how the CME involved. And then we put this cone model into the MHD simulations. MHD stands for the magneto hydrodynamic simulations. So it's normally used for simulate the solar wind and current mass ejections. And then we can get a better prediction. Well, but one thing is still missing in the current prediction system is we cannot predict the magnetic field that after the CME arrives. We call it a magnetic cloud. So this is the magnetic field ejected from the flux rope that on the solar surface, and we still don't know the structure of that. So to do a better prediction, we do need the magnetic field information contained in this flux rope.
Right.
So that is what we are doing. So because we simulate the CME eruption all the way from the solar surface all the way to 1 AU. So in the current model we're developing, there are magnetic field informations that can predict the southward BZ, hopefully.
Yeah, yeah.
But this is still a research field. Yeah.
So, but we've got, I mean, at this point, you know, we've got the launch of the Parker Solar Probe. You've got ESA's Solar Orbiter spacecraft. You've got the newly built Daniel K. Inouye telescope, which is on Haleakala. 3 powerful new instruments that are all going to be observing the sun. How does this change? How do you expect this is going to change your view of the sun?
That's just a great question, Fraser. So this is what make a big changes. So that's start from the Dickest. So I think you already see the first light image from Dickest, that it give you this very high resolution and in both the temporal and spatial of the convection motion on the surface of the sun. So, but the Dickest will provide more in just like 4 or 5 months from now. So the Dickest can provide is actually the diagnostic of the coronal magnetic field. So, and again, in the high temporal and spatial resolution. So these things has never been done in this high temporal and spatial resolution before.
Right. Yeah, I know that they've only got just a couple of the instruments on board. There's still more coming online over the course of the summer.
Right.
Yeah.
Yeah. So the big thing about that is we can directly observe the flux rope magnetic field for the first time in history, I would say. That is a really exciting. So because the big problem of a space vessel forecasting that we still don't know what is exactly the magnetic field that erupting from the sun. So we have indirect observations like from SDO, so Solar Dynamic Observatory. We see the hot channels in the EUV, and also we see it in the white light. We can see the flux rope structures in different bands, but we don't know the exactly magnetic field. And it is, but the Dickest will give us this first chance to see it.
Yeah.
So that will make a big difference, that we will understand better what is erupting from the surface of the sun. And for the Parker Solar Probe is another flagship mission of NASA. So it get into like 8 solar radii, which is very, very close to the sun. Compared to the Earth, Earth is at 215 solar radii, so it's about 4%.
Yeah, so
distance.
close.
So it's very into the sun, and the big thing is that it's actually into the Arfan surface. So I don't know if you know what is Arfan surface. So basically, that is the surface that Arfan speed is equal to the solar wind speed. So inside that surface, so you're gonna see, because the wave speed is larger than the solar wind speed, so you're gonna see the wave propagating both outward and inward. So you're gonna see how the solar wind is heated, and this is another important thing, can improve the model, because the model normally assumes certain kind of coronal heating mechanism. But there's several mechanisms And I think both of the mechanism have certain role in the coronal heating, but we don't know how much. So this Park Solar Probe give us a better idea about that. And also the solar orbiter. This is another big thing in the next couple of years. So the big thing of that is going to the high latitude, and it has a magnetic field measurement of the solar surface. So you're gonna see the magnetic field of the polar region that we don't see before. So this magnetic field will be also very important for the space weather prediction, because we need to use that observations and inner boundary conditions to drive our model. But currently, the model is not driving directly by the observations, but on some kind of assumption. So all of this will improve the space weather prediction capability and the model, of course. Yeah.
I know that, I have some friends in the astronomy community, and they describe like solar plasma magnetohydrodynamics as like some of the most complicated math that is out there. And so I can see why making those kinds of predictions is just so difficult. And even your computers just give up and they just don't want to work on it anymore. So to be able to get more data closer to be able to start mapping out those predictions is really important. We have not seen, obviously, the sun is the most studied star that we have access to. We are starting to get a much better sense of what's happening on other stars, especially with the M dwarfs and their enormous super flares. What do we think other stars like our sun? Do we think that the environment around the sun is just like, if you put that much hydrogen in that place, that's what you get? Or are different stars like the sun similar or different, do you think?
Well, in that sense, I think the sun is just a normal star that is a G-type star, and it has a convection zone. So I think the physics of other stars' work is very similar if they have a convection zone. So
right.
in that case, yeah, it means the I, K, M, and G stars. So all of them have the similar physics and have the magnetic field, and so I think we're really in an era that we can transfer the knowledge we obtain from the solar observation, because that is the only observation we can have a spatial resolution, right? For the stars, we do not have the spatial resolution. So we can use that knowledge we gain from the solar to apply for the other stars, and also I think it's not only a golden age for the solar physics in next decade, but also it's a golden age for the exoplanet and stars,
sure.
because we have TESS and we have WFIRST in the future. We have JWST. So all this data combined, I think, is enter into a golden age for the solar stellar connection studies.
So let's imagine that you have a time machine and future you shows up with an envelope with an answer in it about the sun, thanks to all of the data that's been gathered for the next 5-10 years by Parker Solar Probe and Solar Orbiter and DKIST, the Daniel K. Inouye Solar Telescope. What would you love to know the answer to? Which question do you find most compelling?
You mean for the solar?
Yeah,
solar
so you get to send a tweet to yourself from the future, packed with information, 255 characters, right? That tells you the answer to something that you want to know the answer to. About the sun. What one question would you love to know the answer to?
Well, for me, I think because I'm doing the modeling of core mass ejections, so a very intriguing question for me is what is the magnetic structures of the flux rope? So if we can know that answer, that will be great. And it can improve model, and it's definitely will give our a better prediction model. And also, if you compare the weather forecast on Earth and the space weather forecast, the major difference is that we really have a very, very limited data and observations in space to do the space weather forecast. So another thing I want to see in the future is that we got constellation missions that we can measure the solar wind on different locations. And I think that is become possible because, you know, the SpaceX, they can launch like 60 satellites in just the one launch. And this will definitely change things. We can send this measurement all over the solar system, and then we can definitely improve the space.
That would be really interesting. Yeah. I mean, the asteroid researchers are sort of thinking of this along the same line. Wouldn't it be great to send out missions to 60 different asteroids? But I can see for sure to be able to just sample the solar wind, the solar weather around the whole solar system would be incredible. So one last question for you. It's been a fairly quiet solar cycle. Any predictions for this next solar cycle?
There are predictions for the next solar cycle. Because I don't do this kind of research or prediction, so I don't know if it is a big cycle or it's a low cycle. But for solar cycle 24, it's a very mild cycle. You don't see many X flares, but sun always surprise us. So, let's see.
All right. Well, I'll pack sunscreen just to be safe. All right. Well, thank you so much for taking the time to chat with us today. Where can people find out more about your work?
I think the best ways to follow my research is Google Scholar. If you search Google Scholar, my name plus some solar and heliophysics, you're gonna find the Google Scholar page. And also you can look at my SETI page, and also I have a page at the Lockheed Martin. So it's also listed in the SETI page. So you can look at my information.
All right. Well, we'll put some links in the show notes. So Dr. Jin, thank you so much for taking the time to chat with us today, and good luck. I hope you get your answers.
Thank you, Fraser.
All right. Take care. All right. Let's move on to the space news portion. I wonder who will end up on my screen. Beth, I want to hear from you first.
All right. So my news is pretty quiet because it's a very light week. The Gemini Planet Imager Exoplanet Survey, GPIES, recently completed its 4-year search, and they're looking for light emitted by gas giant planets. They were observing 531 stars, fairly close to the sun, and they were direct imaging, basically looking to direct image planets, and they turned up so far 6 giant exoplanets and 4 brown dwarfs. So pretty exciting just to get that. And I don't know if you can put the images up.
Yeah, I'm putting the image up right now so people can see it. And it's just, oh, there's a video here, but the images, like, these are planets.
Yeah.
Right? Yeah. I'm putting my mouse over these planets. There's 3 planets in this one here. In HR 8799 C, D, and E. That is mind-bending.
Yeah. So they use adaptive optics, and it's installed on the Gemini Observatory, and so they've just been spending the last, I think, 4 years observing this, and they're starting to get the results in, and so we get to see these big planets actually going around the sun. And we do have videos that are basically time-lapse images of, you can actually see the planet's orbit. Particularly 51 Eridani B has a really good video for it.
I remember
you can actually kind of seeing it go around.
I remember one of those came out, I feel like it was like last year or so, or maybe 2 years ago. We saw one, and now here's multiple ones with multiple videos of planets going around stars. That's
And then we've
that's
also
insane.
they've also directly imaged circumstellar dust disks, so you can actually see the light getting scattered by the dust that's going around the stars. So that's the second image on the page.
Yeah, yeah.
So they're basically, you're looking at the leftovers of planet formation.
Just
And
amazing.
that's where we're hoping that at some point we can actually image the smaller planets that are within those dust disks. So that's the goal. But right now, unfortunately, adaptive optics only takes us so far. So we're having to look at big stuff still.
But this is, I mean, this is really a sneak preview of when these next generation monster telescopes come online. Like the Gemini is in that 8.4 meter class telescope, so not quite as big as the Keck, the twin Keck telescopes, but they're big. And there's Gemini North and there's Gemini South. And so you've got these two incredible telescopes. But just imagine when you've got that same equipment, coronagraph, but it's attached to a 39 meter telescope.
Yeah.
Yes,
so
please.
going from 8 to 39 would be amazing.
Yeah, yeah. And so you can see how these techniques are being worked out now with these little tiny baby telescopes for when the monsters come online and they're able to directly observe these telescopes. Absolutely stunning work.
And it really shows you the power of what adaptive optics can do. So you can take existing telescopes and add these adaptive optics to it, and you can actually use them for even better stuff.
Yeah. I mean, as long as you can see through the Starlinks. So now they've been able to figure out how to see through the atmosphere, but next they have to be able to see through the Starlinks. So yeah.
Yeah, getting through all of our own constellations should be fun.
Yeah. Thanks, Beth. Brian, what have you got for us?
I got a couple of things. One of the things is if you are home with kids and are desperate to find activities for them to do, which I'm sure many of you are, there are some interesting astronomical events coming up that you can see with the naked eye, or you can use a small pair of binoculars or a small telescope. One of them is the greatest elongation of Venus. And basically, Venus is inside the Earth's orbit, so it's always relatively close to the sun. And you can never be high in the sky at midnight because it can't be behind the Earth. And greatest elongation is the point where Venus is in angle as far as it can possibly be from the sun. And so that turns out to be about, I think, 46 degrees, 47 degrees, something like that. So that happens on March 24th of this month. So it's the 24th. And it happens to be a really good time because we're very close to the spring equinox. And that means that the orbital plane of the solar system relative to the Earth is high away from the axis. So it's not, sometimes the orbital plane can be low depending on the season, but the ecliptic, what we call, is high from the horizon. And that means when Venus is at greatest elongation, it's actually really high in the sky. So it makes it very easy to see, even if you have buildings on the horizon, even if you have a lot of light pollution.
Yeah.
It'll look like the brightest star in the sky, and it won't twinkle. And so one of the projects you can do with a kid is have them at the same time every night after sunset. Try and estimate how high Venus is above the horizon and watch it as it gets a little bit higher and then a little bit lower after the 24th. The other thing is that sorry, go ahead.
Oh, I was going to say that the greatest elongation doesn't, I mean, it's a time when Venus is bright, but it doesn't quite match up with the maximum brightness, right?
No, it's not the maximum brightness. And that's because if you were to look at it with a pair of binoculars or a small telescope, if you look at Venus, what you'll see is it's kind of in half phase, like a half phase of the moon. And that's just because of the angle. And so there are times when it's closer to the sun and more of it is illuminated and then it's actually brighter. But this is still going to be quite bright. So if you have a small pair of binoculars or something, you can look at the phases And that's exactly what Galileo did to find that Venus is actually orbiting the sun. And so if you can see the phases of Venus, that's kind of a cool thing.
Yeah.
So that's one project that you could do with kids. Another one is if you want to get up early in the morning, there is a conjunction just before sunrise, like around 4 o'clock in the morning in New York Eastern time, of Jupiter and Mars, both of whom are bright. Conjunction means that they're going to be fairly close together in the sky. This happens, the closest one is at the 20th. It'll be about 40 minutes of arc, so a little bit less than a degree. The width of the moon is half a degree, so it'll be about 1.5 moon widths apart, which is pretty close. And so that's kind of a neat thing to see as well.
Yeah, and there's also a bright comet that is starting to make its way. I think it's, is it Atlas?
I
Yeah,
think that's right.
Atlas C 2019 Y4.
That sounds right. I've seen some pictures of that.
Yeah, yeah, and it's shaping up to be probably naked eye visible, which is kind of, I mean, what was the last one we had? Comet something? McDonald's? No. I'm sure someone's going to post in the chat. And that was really only visible to people in the southern hemisphere. And then before that, it was like Hale-Bopp and Hyakutake. So, awesome.
So yeah, there's interesting things to check out if you're wanting to occupy your kids.
I'm not sure why, but my computer is really freaking out. I don't know why. It's very slow. So
everybody's using Zoom.
Everybody's using Zoom. That's it. It's Zoom, of course.
Yeah. I had problems on a call earlier today.
Yeah. That's the downside of everybody being on Zoom. Okay. All right. I'm going to try shutting down. Actually, you know what? It freaked out when I went to this webpage. So let's see if that fixes it. Okay. Moya, what do you got for us?
Hello. I will be talking about ice on Mercury, which might sound a little counterintuitive because Mercury is the closest planet to our sun. It's not the hottest planet, that's Venus, because of its really thick atmosphere. But Mercury in the daytime does get up to about 750 degrees Fahrenheit. So you wouldn't think it has ice on it, but it does. There are these craters near the poles of Mercury that have permanent water ice in them. That's because these craters are, they never see the sun, so they're always cold. This ice isn't anything new. We've known that the ice exists for almost a decade since Messenger went to Mercury and sent back data saying, hey, there's ice on the surface of Mercury, but we didn't really know how the ice got there, or at least how that much ice got there until now, when a team at Georgia Tech came up with some models for how the ice could get there. And it actually is really interesting because the method depends on Mercury being so hot. So one of the other things that Messenger told us, aside from the fact that there is ice on the surface of Mercury, is that some of the minerals on the surface of Mercury are something called hydroxyls. So those are little molecules that are made up of oxygen and hydrogen. Water is also made up of oxygen and hydrogen. So if you can get them to combine in a really cool way, then you can get water. And so a lot of different things, or a few different things, need to happen for these hydroxyls to combine to become water. But Mercury creates the perfect storm for that to happen. So the high temperatures on Mercury energize the hydroxyl molecules. So they're moving around really fast, which means they can crash into each other more often. And when you get these hydroxyls to crash into each other and you add a proton into the mix, then they can create water. And you get the protons from the solar wind. So the sun is always giving off this wind of charged particles. And because Mercury doesn't really have a magnetic field to protect itself from the solar wind, it's constantly being bombarded with protons and other charged particles from the sun. So the high collision rate of these hydroxyls plus protons from the sun make water. And those water particles, a lot of them will be, not dissolved. They'll evaporate away from the heat. Some of them will get carried up into the atmosphere. And when that happens, they'll be transported around the planet and end up at the poles of Mercury, where they can fall into these craters and stay there.
So is it almost like there's snow, like it's snowing on Mercury over time from these water particles that have been created from this interaction with this, and then it's making its way around and then falling into these permanently shadowed craters and building up.
I don't think it looks like snow the way we have it
It
on
should be
Earth
like
because they're not
particle
that
by
big.
particle.
Yeah,
Yeah.
it's tiny, tiny little frozen ice particles. But yeah, if you can see things that small, it might look like a snowstorm.
Yeah, yeah. And then but I mean, and it is building up. So I mean, they think there might be
Yeah,
permanent deposits of water ice in these craters, and this is how they got there.
yeah. So that's the models that the team at Georgia Tech ran predict that about 10% of the ice that they think is there, that they know is there, formed in this way. And the rest of the water would have been deposited on the surface of Mercury from things like asteroid collisions or, other stuff in the solar system depositing itself on Mercury.
It's interesting to think that even Mercury would be a place that you could theoretically harvest resources, hide in the shadow. You got lots of solar energy. There's water available to you. There was another piece of research that came out just a couple of days ago. I don't know if you saw. They looked at this. There's these jumbled up pieces of terrain that are on Mercury, and they were thinking that in fact there was a lot of like potentially water, but also just other volatile gases and such that were underground, and a lot of this left Mercury. And as Mercury was cooling and collapsing, and it was part of the reason why that you've got that crazy jumbled terrain, is that these are regions where some of this material just blew off of Mercury and out into space as well. So
So cool.
we need
I
to go
didn't see that,
back.
but I'll look it up.
Yeah, I forget what they call them, chasmas. Anyway, yeah. So those one of the other discoveries that Messenger had made was these really cool, weird, jumbled up terrain, and they figured it had something to do with the way Mercury is shrinking. But in fact, they think now that maybe it was from some kind of material getting blown out while this was happening. So yeah, I'll send you the link.
Yeah,
Very cool.
thanks.
Yeah, we have to go back. I mean, I
We
guess
do,
we can't
yeah.
be Columbo's on its way, so.
Right. Yeah, Messenger went out in 2015 its mission was over, so
Yeah, that feels
it's
right.
been some time.
Yeah, right on. Brian, you had another story for us.
I did, yeah. So this is the type of story I really like because it's something that is common in astronomy and not as common in some of the other sciences, which is when data becomes public. So this was about the LIGO project that looks at gravitational waves, and it measures the mergers of mostly black holes, sometimes neutron stars in a black hole, but these mergers of black holes create these gravitational waves, and LIGO and Virgo pick them up. And so this has been, the Nobel Prize winning discovery of a new way to look at the universe using gravity instead of light. And both LIGO and Virgo have done 2 sets of runs. They are currently finishing their 3rd one. But one of the nice things about astronomy is that when data is gathered, it is generally, in time at least, released to the public. And so the first 2 runs of LIGO and Virgo are publicly available, and literally anyone can access the data and analyze it however you want. And it's just one of the cool things about astronomy, that if you wanted to be a gravitational astronomer and you wanted to get the data from LIGO, you could do that. And so recently a team looked at this data and went through it on their own. And what's really powerful about this is that LIGO is very sensitive, but it's also, when we make a detection, it's very dependent upon the models that we have. Basically, the signal is so jumbled within the noise that you need a model of what to expect in order to pull out what the signal actually is. And you can do this properly, but anytime you do this, there's always going to be some people that are going, yeah, you're using your model to prove that your model's right. That's not science. And so this new team decided they were going to go through this same data. And they had their own model. And because it's publicly available, they could just filter through it. but they added an extra part to it. And that was knowing what signals are like now that we can see different types of signals. They also added a statistical layer to it, where they would look at a statistical modeling of the same trends of behavior. And so when they ran their model through the data, they found 14 events, merger events, that had already been confirmed by LIGO and Virgo. Then they found one more.
Oh, wow.
And LIGO and Virgo had detected it, but couldn't confirm that it was a merger. And this new model and the new statistics could. So we now have an extra merger by bringing this data public.
And
I think that's just the coolest thing.
And so does that mean that we pretty much now have this will be the preferred method for confirming discoveries in the data?
It could be. I mean, whenever you apply a model, particularly these really complex ones, there are pros and cons to how you analyze the data. And so, you don't want to err too much on getting false positives, but you don't want to miss the real signals that are there. And so there's always a balance point. And this is one of those things that's always going to be debated. What's great about this is that when you bring in multiple techniques and multiple methods, you get a more robust model. You can confirm things more strongly. So one of the things that the team did is they also looked at the statistics of a neutron star and black hole merger, which is one of the things in astronomy we really want to see, because that will help us understand the structure of a neutron star. Basically, as a black hole rips it apart, the waves that it makes, will tell us about how it's built, what its density distribution is, and all that. So they tried to analyze the statistical method here, but there aren't enough events yet to find any new ones. So they didn't find anything new of a neutron star merger. But the method could be used, say, in run 3. Mm-hmm. So as you add run 3, as we find more data, this statistical method is going to get more accurate, particularly for things that we're really looking for.
Unc Willie asked in the chat, are they digging through optical and radio data to confirm it? Do you know if anyone's gone looking for them in other ways?
So in terms of a black hole merger, there isn't an optical or radio data to confirm it, because these pure black holes don't give off light with the merger. The ones that you will see that will be bright in either optical or radio or X-rays will be something like a neutron star and a neutron star, or a neutron star and a black hole. Those have, and the events that we have confirmed have had also optical light confirmations.
Yeah. So before we wrap up today's episode, I've got a little time sort of at the end, and I wanted to have a bit of a roundtable conversation from my co-panelists here, many of whom are already very familiar in working from home, in the home office life. And just, I'd love to sort of hear some people's ideas on resources that people can use, places to go, ways to entertain yourself, ways to continue educating yourself as the potential quarantines get more and more strict. We're going to be spending more and more time trapped within our walls, waiting for the wave to pass. So Moya, do you have any recommendations for resources that people might want to get access to while they're out there on the internet?
Yeah, I am always a fan of learning new skills when I'm stuck at home and I'm given the time to do so. And there are a bunch of places online where you can do that, anywhere from like academic classes like Khan Academy, or online classes that you can take there, or skills classes like Udemy or Skillshare is a pretty good one. Yeah, that's what I'm going to be doing with a lot of my time at home.
I'm doing Duolingo. I'm teaching myself Chinese. So
nice.
Yeah.
I'm teaching. I have finished all of Irish. I've been doing that one for 5 years, so I decided to start Spanish. So now my Irish lessons are actually moving into actual textbooks. I have a friend of mine who actually teaches it. So
That's amazing. I took
now I'm doing
Irish in
Spanish.
college.
Well,
Yeah?
Duolingo
I did.
keeps telling us that there's more people who speak Irish through Duolingo than actual native speakers of the language.
Yeah,
It's a really cool language.
it is a cool language.
Brian?
So I think, the standard of get dressed every day, follow a pattern, all of that. But I think one of the most useful things that I've learned is we tend to measure productivity at work by being at work, and we tend to measure productivity at home as I'm actively on task. So it feels when you're working at home like I'm not really working as much. And that's because if you're in an office, you discount, oh, I spent a half an hour talking to a couple of people, just maybe thinking about casual things or ideas, but I was just chatting, or I went down the hall to get coffee and came back. And you don't see that as not being productive because you're at the office. But if you're home, you go, well, I've worked on an article and then I went off for 15 minutes to load the laundry. I'm wasting time. You're not wasting time. You're getting coffee. Instead of getting coffee, you're doing a laundry thing. Or instead of talking with colleagues, you're arguing with your kid about why they need to do their homework. This is at home, you devote your time, but it's still going to be mixed up. And we see that as being broken at home, but we don't see it as being broken at an office.
Yeah.
And I think that's one of the biggest things is don't beat yourself up because you constantly feel like I'm not being productive. It's going to take time to find a pattern. And because of this situation, everyone's productivity is going to be shifted.
Yeah, and it's so important to just realize that we are going through something that humanity hasn't gone through in 100 years. And
this is generation defining. This is what my kids' generation is going to be defined by. Remember that year where we all got out of school and didn't have to go back for 6 months, know?
Mm-hmm.
And
or the people graduating right now, and how are you supposed to get a job at this moment? You know?
Right.
Yeah, you graduated, but you just get to spend time with your parents more.
And that's one thing that I would say to encourage both kids and yourselves. If you don't have a journal, start a journal.
Mm-hmm.
Not only because it'll help you process all the things that you're going through, but also historians will love to look at these personal accounts of personal events in this, generation defining period in time.
It's interesting. My son is 16, and we've been working on his schedule of the things that he's working on, and I was thinking of pitching that he read Diary of Anne Frank, because under the sort of the horrors of what's going on, it's really about a family that's hanging together in a very tight circumstance, just finding joy in the day-to-day moments that they can. And I know exactly what you mean, that it feels like we've got to hit the ground running as hard as we can and just keep this going. But literally, if we don't leave the house and don't infect people and don't get some of the elderly sick in our society, we have done some of the most important work that we can do in our lives. Literally, all we have to do is sit at the couch and watch Netflix, and we are making the world a better place. And I think it's important to keep that all in perspective, because it is.
As Craig said, it's a marathon, not a sprint.
Yeah. Beth, what have you got for us?
So aside from finding a routine, which I think the thing that's kind of ease off on my own expectations, and then if you're looking for stuff to learn, there's Skype a Scientist for kids. They have a 3-week schedule out right now, and basically once a day they do a Skype on a different topic. Today they were doing, I think, infectious disease in animals. Friday or tomorrow is fossils. So they have all kinds of different things. You can subscribe to their newsletter and they'll send those out, and you can watch them and ask questions of scientists. Also,
That's
going back
really
and
cool.
going back and revisiting some of the old crash course videos on YouTube. those are great. I'm recommending obviously the astronomy ones to everybody because Phil Plait did a great job. And so if you're looking for things to, give your kids information in a way that is accessible, that's another great series to watch.
Yeah.
So just look for the things that work for you, and don't let the schedule that goes around that's like, here's how you should live your life be how you live your life if it doesn't work.
Yeah. And I think go ahead, Moya.
Beth, what you said just reminded me of the fact that I've been a night owl my entire life, but I've been forced to be on like a early riser's schedule. Now is my time to shine.
So much getting done. Yeah. That's awesome. It's and I think the other thing that I think is really important is that keep an eye on your mental health, because you can just catch yourself being in this place where you just every 5 minutes you go back and look at Twitter again and scroll a little farther, and you see the different hashtags that are trending and you're looking for updates. But the reality is, like, unless something really critical is happening, unless you or your family is sick, it's not going to change that much for you from a day-to-day basis, and you will get all the news. And some advice that I read that was really good was just check once in the morning. Just check a national source, check a local source, give yourself 10 minutes to really just, get your dopamine receptors all full, and then just go about your day and just fill your time with other interesting things. And then come back around the next day and you'll see that things have progressed, and you won't get the closure that you wanted, but you'll be all right. And I think I catch myself just in this anxiety worry state, which I know is not a good thing. And so I've been really taking a lot of effort to avoid that.
I find it funny that I actually walk away from the internet more now than I did 3 weeks ago. When I was working at home and already doing that. And now it's like, I don't want to. The other thing I recommend, use Discord. My friends and I, my personal close friends that I hang out with all the time, who we don't get to see each other right now because we are in a shelter in place. We've created our own Discord. We're planning movie nights and game nights and trying to keep ourselves in contact and occupied and always having someone to talk to, so that you don't feel completely closed off if it's not what you're used to. I'm an extrovert. I work from home by choice, but in the evenings I like to go out. So that's where I'm really struggling, is the social side of it at the end of the day.
Yeah, I'm very similar, an extrovert who happens to work from home. All right, well, we're reaching the end of our hour. Beth, you're on my screen. Where can people find out more, and what are you working on?
I am at Planetary Pan, basically everywhere. And on Twitter right now, I am running a series of very silly science polls to kind of do really rudimentary science and keep people entertained. So we've done things like, when are you most productive on Twitter? Do you hate cilantro and also hate IPAs or no? And I think we're going to be working on a how do you like your eggs bracket.
Right.
So that should be coming up probably tomorrow. We're sort of fleshing it out. There's just other random people on there with me who are like, that sounds fun, let's do that. So come hang out on Twitter and do some really silly science. Come up with poll questions we can answer.
Never yes to both cilantro and IPAs and scrambled. Moya.
You can find me on Twitter and Instagram. I'm at GoAstroMo. And I have two really exciting pieces of news, actually. The first one is that I just finished a paper. So I'll be submitting that tomorrow, I guess. And I got a book deal.
What?
So I'll
Congratulations!
Oh, that's amazing.
Thank you.
Also, I'm sorry.
Yeah, I don't really know what I'm in for yet, but I'm really excited. It's today.
Do you know the title or the gist?
I don't have the title yet. At least I proposed the title, but I'm not in love with it. The idea is that it's a book about the history and evolution of the Milky Way, but I'm writing it from the Milky Way's perspective, as if it's writing its own autobiography.
That's very cool. Brian.
Yeah.
You can find me on my website, which is briancoberline.com, or on Twitter at briancoberline. You can also find me at the Esteemed Universe today when I show up with an article from time to time. That's pretty much it. So that's kind of what I'm doing at the moment.
And you've got a bunch of recent articles that you
I have
talked
a
about
bunch of
today.
recent articles.
Yeah.
So yeah, I'll probably be doing more articles now that my other NRAO job is in kind of standby mode.
Right.
So
Yeah.
I've got more time.
Excellent. Okay. Well, of course, I'm at the universe today on all the things. We took a little bit of a break this week, just sort of dealing with all of the, me sort of reassimilating my children into the household. So we will be back at it next week with a bunch of cool stuff. I think I kind of want to do a video on Mercury now. Well, you got me kind of stoked on this new research. So thank you for
Good.
that.
Yeah, and send me that link.
I will. All right. Let me put everybody up on the screen here. There we all are. So, as always, thank you everyone for watching us. Thanks to all the moderators in the comments. Thanks especially to Nancy Graziano for all of her work behind the scenes, and special thanks to Beth for sorting out this week's guest. That was amazing. We will see all of you next week.
Bye.
Bye.